Hello everyone, you are all welcome to lecture number 1295 and it is in continuation of laser technology, or we can call it laser beam or laser devices, how they are producing laser. In previous lecture I have given you some background, and today I am going to discuss how the concept of laser technology and laser light started emerging from 1917, and from 1917 to 1940 they were very good scientists and they were having lot of concept, theory, experimentation about the subatomic particles. And the first idea was coined by Albert Einstein in 1917 that atoms, when they get energy or when they are heated, they will go to higher energy state, and once they will come back to its ground state, there will be release of energy in the form of photon. And that was the first concept where the quantum mechanics came. Quantum mechanics means the quanta of energy and how electron is behaving. That was the biggest discovery. And then de Broglie, Bohr, they were all together and they were working a lot on subatomic particles like electron, proton and neutron. And mainly they were on ordinary light and then laser. So let me make it clear here, give you very clear picture of laser and ordinary light. If I say ordinary light means any source of light like sun. If you have sun is having multi-direction. In all direction, multi-direction, low intensity, wavelength, light is coming. It is not in one direction. It is having many directions. In all direction you can say, with different wavelength, with different frequency. So that ordinary light, sunlight, even our tube light or this bulb light, they are all ordinary light because that light is not focused, is not concentrated, is having different wavelength. But when we are talking of converting this ordinary light into laser, means it is in one direction and amplified. All these are aligned frequencies, all aligned frequencies, and it has one direction, and it is not multi-direction, and it is having single wavelength, monochromatic, one color. That is called laser beam. And the intensity of laser beam will be high. That's why if you bring your finger in front of sunlight, just in front of sunlight, it is only 1 watt intensity. You will not feel anything. But the same, once it is focused to single wavelength, the intensity will become very high, and once it is falling on your finger, it will burn immediately because the high intensity, high energy is there. So that is called monochromatic light, like sunlight, rainbow. Rainbow is the combination of different color you might have seen in the sky. But once they are merged, it is without any color. But that color, what you see in rainbow, is of different wavelength, different frequency. So that is here we have to be very clear of how ordinary light is converted into laser beam, and it got time to time advancement. So from 1918, then it came to 1953-58. Then the concept of again was there, that how the microwave was developed in a high intensity microwave. And then finally in 1960s, 70s, then ruby laser was developed. So ruby laser means synthetic ruby rod, that is aluminum oxide, was doped with chromium ion, and that chromium, once some light is falling on that chromium ion will emit the photon, and that photon will be colorless without any we can say multiple direction. It will be in one direction, and it is going to knock so many other chromium ions, and in this way chain reaction will take place, and you will get the ruby red light. And ruby, if I say ruby synthetic rod, means aluminum oxide doped with chromium, so it will be having deep red color. And from there, once it is converted in the form of photon, that is chromium ion emission, amplified those photons in the form of radiation, that is called laser. I mean the light which is amplified, and then it is radiated with energy, that is called laser light, and that was the first discovery of one American scientist that I have already mentioned. So let me show you some of the pictures. So here this is the image of ordinary light, maybe high powered LED bulb or tube, and in all direction, multi-direction, and it is shown with low intensity of energy. This is called ordinary light, and I have already told you the example of sunlight. This is the image of laser beam or monochromatic, or you can say concentrated form of light, which the diameter of bright light is in one direction, concentrated in a single direction, and all lights they are following, they are not going to spread, they are not spreading, rather than they are following the one direction, and they are concentrated, they are focused. Such type of light is called monochromatic light, and it is laser beam. This is actually very clear picture of laser beam, where all the wavelength they are very much overlapping, similar type. They are same type of wavelength together, and that is called laser beam. And once, and it is monochromatic, means single wavelength, single color, and that is why in laser different fluorescence are coming, because of the single wavelength which gives its own specific color. That is very clear here. And once it is of different wave, like I have already told you that of rainbow. This is exactly rainbow. Rainbow is showing you red color, yellow color, blue color, and it shows that this light is not monochromatic, rather than it is the combination of three wavelengths. One is shorter, one is longer, one is medium. Shorter means blue color, longer means red color, and the medium is yellow color. So that is not actually monochromatic, rather than it is polychromatic. So that is the best example of rainbow. So this is the best example of colored fluorescent laser light. So one is greenish in color, one is bluish and the other one is reddish color. So, but they are concentrated in one direction. They are not going to follow multi-direction, and at the same time they are monochromatic. Their wavelength is single, not multi-wavelength. So this is the best fluorescent example of laser beam. So here, laser device means that device is capable of converting that ordinary light after the bombardment of that ions in atoms, and then it is releasing the photochromic light, and that is in concentrated form in one direction is called laser beam. And here it is having only one wavelength, that's why it is green in color, only one color, that is monochromatic light. So here the same thing what I explained is given in the form of summary. So note down the summary. Number one, that was how the advancement started. I have already told you that in 1918, Albert Einstein proposes the concept of stimulated emission. What he made his suggestion that an atom could release excess energy in the form of light, and that was photon, and they call photon as a quanta, and from there onward the concept of quantum mechanics started in physics. And when we are saying quantum means, they mention then de Broglie and Bohr, because they were of the opinion that all these electrons, they are particulate, they are particle. But de Broglie said no, they are wave. So there was lot of research publications on that concept of dual character or dual nature of electrons. Sometimes it was behaving as a wave, and sometimes it was behaving as a particle. So de Broglie gave his very clear experimentation that this electron is in the form of photon, and that photon is nothing but quanta, is a bundle of energy, and this photon is particle. They said light particle is nothing but wave. But atomic particles, they are electron, proton and neutron. So that was the concept, and when stimulated by light. In 1920, the scientists Neil Bohr, Schrodinger developed the theory of quantum. I have already told you that came to quantum mechanics. The concept of photon was the main groundwork for laser, to understand the laser concept. Laze. The word laser came from laze out. Then in 1953, Charles Towers, an American who invented the microwave amplification. So once the microwave amplification was done, it was great discovery. After that, lot of instruments, lot of oven, lot of different type of lab equipments started coming in the form of, in the name of microwave instruments, and that was amplified, and that opened the door for laser beam technologies. Then in 1960, I call him father of the laser, who developed the workable, practical, because up to that time it was lot of theory was involved, but in practice he developed the laser from synthetic ruby, and his name is Theodore Maiman. And Theodore Maiman, he died in 2007, and he was really or he is even till today the father of laser beam, and who developed the ruby laser, and then lot of other improvement and research and development came. So here in 1960, Theodore Maiman, an American physicist, worked on laser, built the first working laser, and using a rod of synthetic ruby, that is nothing but aluminum oxide doped with chromium ions. And ruby rod has deep red color due to chromium doping. Ordinary light, it spreads in all direction, multi-direction. It is broad spectrum, contain wide range of wavelengths, which I have shown you, that rainbow color spectrum. Ordinary light has low intensity and low energy. Laser beam, it is highly directional in one direction, very much concentrated, focused. You have seen the images of all those laser beam with a very narrow beam. Laser beam is very narrow, and that's why it is known as centered or concentrated light. Also, it is narrow spectrum, means single wavelength. It is not having different wavelength with different colors. It is single wavelength. That's why it is monochromatic, means one color. And single color, that is monochromatic. And laser beam has very high intensity with small distance spreading. But here it is very much focused onto a tiny area. Any tiny area can be focused with laser beam. But ordinary light spread with small distance. In any small distance, it will be having big area. But laser, it will be very much concentrated, focused in one direction, and even with lot of distance, with minimum diameter. So with this I will stop, but I am going to continue on laser beam, because after 2000, lot of new technologies are there, and laser became the part of our life everywhere in medicine, surgery, military. So I am going to discuss that part once again. Thank you very much for watching the lecture.